This is section 2.5 and it's the second video of this section. And once again, we are solving polynomial equations, so we're finding the zeros of polynomials. We're going to continue solving equations with that three-part process we learned in yesterday's video. And so here's our equation. We want to find all the zeros. Now remember, the first thing I need to do is find all the possible rational zeros using that rational root theorem. So we need to find our p's and our q's. The p, if you remember, are the factors of our constant, so negative 20. So we'll have to list out all those factors. 1 plus or minus 2, 4, 5, 10, and 20. Now our q's, just plus and minus 1, that's all the factors of the leading coefficient. So p divided by q really is just going to give us the answer of all these p's here. The next step would be to find our number of possible positive and negative zeros using Descartes' rule of signs. Remember, to do this, we need f of x, and we also need f of negative x. So let's find f of negative x. We're going to put a negative x in place of all of our x's and simplify. So we get negative x cubed. Our x squared is going to stay positive, minus 11x minus 20. So to determine the number of positive zeros, we're going to look up here at f of x and count the sign changes. So if I look at f of x, it looks like I have a positive to a positive, positive. My first sign change happens here at the end. So there is one positive zero. We do the same thing with negative x, and it looks like I have one sign change, another sign change, and then that one stays the same. So there's two negative zeros. Remember, we'll have to subtract 2 there, so we're going to say there could be 2, or there is a possibility that there are none. Now I know out of that big list there, up at the top here, of our p over q's, our possibilities. Out of all of these possibilities here, I know that one positive will work and either 2 of those negatives will work or neither of them. So we're going to use those to help us now moving forward. We're going to go ahead now and start using our synthetic division to actually see which one will work. So let's go back for a second. There we go. So we'll just pick one to try. I'm just going to start with positive 1. The reason I'm going to start with the positives is because I know for sure that one positive will work. So we'll start with positive 1 and we'll do synthetic division. Remember, the goal here is to get a remainder of 0 because that means that that answer is in fact a root or a 0. We'll drop down the 1 and multiply and add, and multiply and add, and multiply and add. And it looks like we got lucky this time. Our 1 worked right away. So right now, I know x equals 1 is a solution. Now, I could go through all those remaining negative zeros and try them all. Or we can take the leftovers, x squared plus 9x plus 20, and try and factor. I'm looking for 2 things that multiply to negative 20 and add to negative 9. Or I'm sorry, multiply to positive 20 and add to positive 9. And that's pretty easy because it's just 5 and 4. The zero product property then would tell me my other 2 zeros are 5 and negative 4. And then of course we had the x equals 1 from earlier. And there's the solutions to our equation. Let's go ahead and look at another example here. So for our next example, we have this time x to the 4th. So we're going to have a little bit more work. Notice that also we're going to have a q value of 2. So we're going to have more options here. Let's go ahead and start by listing out our possible zeros. So our p's are the factors of 15, plus or minus 1, 3, and 5. So 15. Our q's, plus or minus 1 and plus or minus 2. So now, p over q, it looks like I'm going to have a lengthy list here. I'm going to put 1 over 1, 3 over 1, 5 over 1, and 15 over 1. And then I have to do the same thing with all the 2's. So we get 1 half, 3 halves, 5 halves, and 15 halves. In order to do Descartes' rule of signs, we're going to need f of negative x. That will be the second step. Step 1, possible zeros. Step 2, Descartes' rule of signs. So we'll put a negative x in for all of our x's. And do a little simplifying here. And now that we've simplified, we need to go and count our sign changes for our positive zeros and our negative zeros. So let's go look at f of x. It looks like f of x is going to have one sign change there and another one here. So 2 sign changes in total. So that means 2 or no positive zeros. In terms of the negative, we've got a sign change here, another one there, and 2 or no negative zeros. Now, this shows me that really Descartes' rule of signs didn't help me because there's 2 or no positives or 2 or no negatives. I don't really have a nice starting place here, so this is an example of a time where you just have to start trying synthetic division until you get some right. So, let's go ahead and do that. We're going to go ahead and start testing some of these zeros with synthetic division. Remember, the goal is to try to get a remainder of 0. If my remainder is 0, then I know that that number would be a 0. I'm going to just go ahead and start. I'm going to choose x equals 1. Let's try that one first. So we'll list our coefficients. And now we'll go ahead and work through synthetic division. So drop down to 2 and multiply and add, and multiply and add, and multiply and add, and multiply. And it's nice, right away on the first shot with x equals 1, we got a solution. So that's great. Let's take a look at what's left. If I write the leftovers, I have 2x cubed plus 5x squared minus 6x minus 15. Now, normally, in the previous examples, at this point, we got an x squared, and we solved using factoring or quadratic formula. Right now, I have an x cubed. I can't use that method. I have to keep trying synthetic division again with more solutions. Now, be cautious here. You would want to try 1 again because 1 could be what we call a double root. It could work twice. So let's just try it right away. Let's try positive 1 again. I'm going to go through some positives because I know that there are 2 positive roots here. We decided that in Descartes there were 2 or 0. Since one of them came up positive, that means there's going to be another positive that should work. Now, when I drop down the 2, I get 2. Keep going. And it looks like positive 1 didn't work. It's not what we call a double root. Now, I'm going to pause here for a minute and we're going to fast forward a little bit. The reason is because we have a lot of zeros to try. We can keep going through the list. I'm going to tell you that if you try every positive number listed there as our possible zeros, you won't get another solution that works. Now this doesn't make sense. We said there are 2 positive zeros. When we find the first negative 0 and then we get the leftovers, you'll see why. So let's just fast forward for a few minutes. Let's try some of our negative roots and see if we can get an answer. Now, because I already know the answer, to save us a little bit of work with synthetic division, let's try negative 5/2. And we'll use, again, just the leftovers now, just the smaller one. You could go back to the original, but if you use the leftovers, the 2x cubed plus 5x squared minus 6x plus 15, this one here, it's a little less to deal with. So now let's go through our synthetic division. Drop down the 2. 2 times negative 5/2 is negative 5. 0, 0, negative 6. Negative 6 times negative 5/2, that actually becomes positive 15, and it looks like that one works. So now we have another 0, x equals negative 5. I have a positive and I have a negative. That means there's 2 more solutions here, one of them positive and the other one negative. Let's look at what was left with my synthetic division this time. 2x squared, no x's, and minus 6. This is kind of nice. This isn't that hard to solve. Add 6 to the other side. Divide by 2. And it looks like we get plus or minus the square root of 3. Those are our other 2 solutions. One positive, one negative. Now those ones weren't in our possible list of p over q's because remember, that's only going to give us our rational roots, our possible rational roots. The square root of 3 is irrational. So had I gone through and tested all the positive numbers after positive 1, I wouldn't have gotten another positive root out of that list because my other positive root was irrational. So we have 4 answers here to this equation. X equals 1, x equals negative 5/2, and x equals plus or minus the square root of 3. Alright, I'm going to give you one that I want you to try. So I want you to work this out, I want you to solve this equation, and I want you to bring your solutions to class tomorrow. Remember, the first thing you need to do is to find your p over q's, your possible rational roots. Then you're going to use Descartes' rule of signs to decide how many positive, how many negatives. And lastly, you're going to use synthetic division to solve and find the solutions.